Looking here at the question, it asks us to set up the elevation and plan of the planes ABC and ABDE. We do this using the X, Y and Z coordinates that are given to us in the question above. The second part of the question asks us to determine the dihedral angle between the planes ABC and ABDE. Now, what we know from that is that AB is the intersecting line between the two planes, or the line of intersection. To set up the question and to help us find the dihedral angle, we are going to have to take an auxiliary view. So we're going to draw an x1, y1 line that is parallel to the line AB and project all our lines perpendicular through the line to the line AB, and that will create our auxiliary view. Now that I've projected all my lines perpendicular through the x1, y1 line, I need to take my heights from my elevation. So the rule for this is you go back 2 views. So the first view would be the plan, the second view would be the elevation. So I'm stepping from my x, y line off my heights into my new auxiliary view. Now that I have stepped off all my heights, it is important to label all your points so you don't get confused when you're constructing the planes. Now we have created an auxiliary view of the two planes, and we have the line AB, which is the intersecting line between the two planes, or the line of intersection. To find the dihedral angle, we need to get a point view of the line of intersection, which is the line AB. To get a point view, we look perpendicular to the line AB. So we're going to create our second auxiliary, now our x2, y2, looking out along the line AB and projecting all our points perpendicular to our new x2, y2 line. Now that I have all my lines projected perpendicular for my second auxiliary view, I'm going to insert a datum. A datum basically moves my x1, y1 line, and I'm moving it onto the point D. This is to save space as I'm near the edge of the page. I'm going to step off all my heights from this datum now. So we're in our second auxiliary. Again, we have to come back 2 views to get our height. Because I've inserted the datum line, I'm going to step all those heights from the datum. Now that I have marked off the height for all my points, I have a point view AB, and what we have here in the second auxiliary is an edge view of the two planes. So it's like we're looking down the two planes perpendicular to the edges of them at 90 degrees, and that way we can measure the dihedral angle, which is basically the angle in between the two planes. Using my protractor now, I'm going to measure the dihedral angle and indicate it. It doesn't ask it for it in this question specifically, but it's a good habit to get into to always measure and indicate the dihedral angle. Having completed part B, we move on to part C, which is to draw an elevation and plan of the point G and determine the distance between point G and B. To do this, we're going to have to create a true length of the line GB. I've constructed the line GB here using my set square, and I've also drawn a horizontal line from G. This is like rebatting the plane around, or rebatting that line around, so that I'm looking at it straight on at 90 degrees. If I have a horizontal line and plan, I know I can find a true length and elevation. So using my compass, placing it on G, I rotate around the length B until it hits the line that I've projected horizontally from G, and I'm now going to project that up to my elevation. The second part of part C of the question tells us that the lines AE and GF are parallel. We know that if lines are parallel in one view, they're parallel in all views, so we can just construct those in our elevation and plan. We have now found the point F, so this completes part C of the question. On to part D of the question. This time we're asked to draw a horizontal line from C which will touch the plane AEFG at a point which is 55mm from C. This is essentially a horizontal cutting plane, and we're going to find this in both the elevation and the plan. Having extended my horizontal cut from point C, I can see that the horizontal cutting plane currently is cutting the plane AEFG, but it is not cutting the plane ACG. So I'm going to extend it to cut the plane ACG. I'm going to drop those points then down to my plan view and find that horizontal cutting plane in my plan. To finish part D of the question, I need to determine and indicate the true angle between the horizontal line that we've just drawn and the vertical plane. It tells us that the horizontal line that we drew will touch the plane at a point which is 55mm from point C. What I need to do now is, with my compass, set a radius that is 55mm, and I'm going to swing an arc from point C. Where that arc intersects with my line KF, which is my horizontal cutting plane. I'm going to extend through that, and that line there now indicates the inclination, the true inclination of the horizontal line to the vertical plane. So again, I project up from my point there to find it in my elevation, and now I'm going to use my protractor to measure and indicate the true inclination. In this case, it's 57 degrees. To finish the question now, I'm going to add some shading just so you can see the planes easily.